Our planet is bathed in the constant glow of the sun, a star that has been shining for over 4.5 billion years. It's a powerful force, driving life on Earth, influencing weather patterns and sustaining ecosystems. The sun offers us a nearly limitless source of energy, one that is clean, renewable, and abundant. Yet despite its potential, we've barely scratched the surface of harnessing its full power. Our current solar technology is just the beginning. Imagine a future where we tap into this celestial power plant from space itself, capturing solar energy directly from orbit. This is the promise of space solar power, a visionary concept that could revolutionize how we generate energy. For decades, we've relied on fossil fuels to power our world, extracting oil, coal, and natural gas from the Earth. But these resources are finite and damaging to our planet, leading to deforestation, pollution, and habitat destruction. Climate change is a stark reminder that we need a new approach to energy. The melting glaciers and extreme weather events are signals we cannot ignore. Space solar power offers a revolutionary solution, one that could provide continuous, clean energy to every corner of the globe. It presents a chance to break free from the constraints of Earth, to think beyond our planet, and harness the vast energy of space. By embracing this technology, we can move towards a cleaner, more sustainable future, reducing our reliance on fossil fuels. This is not science fiction. Researchers and scientists are already working on the technology needed to make space solar power a reality. It's a tangible possibility within our reach, poised to reshape our world in the 21st century and beyond, transforming our cities and landscapes. Join me as we explore the exciting potential of space solar power, delving into the science and innovation behind this groundbreaking idea. Together we will discover how this incredible technology could power our future, providing a sustainable and abundant energy source for generations to come. Our world is hungry for energy. Every day we consume more and more power to fuel our modern lives. As populations grow and technology advances, the demand for energy increases exponentially. Cities expand, new buildings rise, and more devices become integral to our daily routines. Our demand for power continues to skyrocket, putting immense pressure on our existing energy infrastructure. By the year 2040, global energy consumption is projected to reach a staggering 30 terawatts. This is a significant increase from today's levels. To put that into perspective, 1 terawatt is equivalent to the power of 1 trillion watts. Imagine billions of light bulbs all turned on at once. That's a lot of light bulbs. And it's not just light bulbs, it's everything from our homes to our industries. Meeting this growing demand is a monumental challenge. Engineers and scientists are working tirelessly to find solutions. Traditional energy sources like fossil fuels simply won't be enough. They are finite, and their extraction and use have severe environmental impacts. They are also unsustainable and contribute to the climate crisis, causing pollution, deforestation, and global warming. We need a bold new solution, one that can provide clean, reliable energy for generations to come. Renewable energy sources like solar and wind are promising. Space solar power emerges as a leading contender to meet this challenge head-on. By harnessing the sun's energy directly from space, we can achieve unprecedented efficiency. It offers the potential for a nearly limitless supply of clean energy transmitted wirelessly to Earth, reducing our dependence on terrestrial resources. Capable of powering our planet without harming the environment, space solar power could be the key to a sustainable future, ensuring that our growing hunger for power is met responsibly. Imagine a fleet of massive solar panels, stationed in space, soaking up the sun's rays 24 hours a day, 7 days a week. Unlike Earth-based solar panels, these space-based systems wouldn't be hindered by night, clouds, or atmospheric interference. They would have a constant, uninterrupted line of sight to the sun, maximizing energy capture. These space-based power plants would be engineering marvels, capable of generating immense amounts of electricity. A single space solar power station could generate about 1,000 megawatts of power, enough to power a large city. This continuous, reliable energy generation makes space solar power a game-changer. It's the key to unlocking a future where energy scarcity is a distant memory. Getting these massive solar panels into space is a significant undertaking, but the rewards far outweigh the challenges. The cost of launching payloads into orbit has been a major hurdle for space exploration. However, with the advent of reusable rockets and advancements in space technology, launch costs are steadily decreasing. Currently, it costs approximately $10,000 to send 1 kilogram of payload into orbit. While this may seem expensive, it's important to consider the long-term benefits. Space solar power is an investment in our future, one that will pay dividends for generations to come. As technology continues to advance, launch costs are expected to drop even further, making space solar power an increasingly viable option. Section 5. Beaming energy back to Earth. Once captured in space, the energy needs to safely and efficiently transmitted back to Earth. This is where things get really interesting. Scientists and engineers are exploring two primary methods for beaming this energy back home: microwaves and lasers. Microwaves offer a proven method for wireless energy transmission. They can travel through the atmosphere with minimal energy loss, even in cloudy conditions. Lasers, on the other hand, offer the potential for even greater efficiency and can be focused on smaller receiving stations on Earth. Both technologies hold immense promise and are being rigorously researched and developed. Imagine a future where energy flows wirelessly from space, powering our homes, businesses, and transportation systems. Section 6. A cleaner, greener future. The environmental implications of space solar power are profound. By shifting away from fossil fuels, we can drastically reduce our carbon footprint and combat climate change. Space solar power offers a clean, renewable energy source that produces no greenhouse gas emissions. Studies have shown that widespread adoption of space solar power could reduce global carbon emissions by up to 70% over the next 50 years. This would be a monumental step towards a sustainable future, mitigating the worst effects of climate change. The transition to a clean energy economy is not just an environmental imperative, it's an economic opportunity. Space solar power has the potential to create new industries, jobs, and technological advancements. Section 7. Space solar power, a timeline. The future of energy is closer than we think. While space solar power may seem like a distant dream, the reality is that the technology is rapidly advancing, and the first pilot projects are already on the horizon. Several countries, including the United States, China, and Japan, are investing heavily in space solar power research and development. These nations recognize the transformative potential of this technology and are committed to making it a reality. Experts believe that the first space-based solar power stations could be operational as early as the 2030s. From there, the technology is expected to scale rapidly, ushering in a new era of clean energy abundance. Section 8. Overcoming the challenges. Like any ambitious endeavor, space solar power faces its share of challenges. However, none of these challenges are insurmountable. With ingenuity, innovation, and collaboration, we can overcome these hurdles and unlock the vast potential of space-based energy. One of the main challenges is the high initial cost of building and launching these space-based power plants. However, as technology advances and production costs decrease, space solar power will become increasingly affordable. Another challenge is the need for international cooperation. Space is a shared resource, and successful implementation of space solar power will require collaboration between nations. Section 9. Investing in our future. Space solar power represents a bold investment in our future, one that holds the key to solving some of humanity's greatest challenges. By investing in this revolutionary technology, we are investing in a cleaner, more sustainable future for all. Governments, private companies, and research institutions around the world must work together to make space solar power a reality. We need to continue to fund research and development, foster innovation, and break down the barriers to implementation. The transition to a space-based energy economy will create new jobs, stimulate economic growth, and reduce our reliance on finite resources. It's an investment that will pay off for generations to come. Section 10. A new era of energy abundance. Imagine a world where energy is no longer a scarce commodity, but a readily available resource. Picture cities that never sleep, powered by the endless energy of the sun, and communities thriving with the assurance of constant clean power. This is the promise of space solar power. By tapping into the vast energy potential of the sun, we can create a future of energy abundance, where everyone has access to clean, reliable power. Space solar power involves capturing solar energy in space and transmitting it to Earth, ensuring a continuous supply of energy, unaffected by weather or time of day. This abundance of energy will fuel innovation and progress on a global scale. With an unlimited energy supply, we can drive technological advancements, support sustainable development, and foster economic growth in every corner of the world. It will power our homes, businesses, and transportation systems, while also enabling us to address some of the world's most pressing problems, such as poverty, hunger, and lack of access to clean water. Imagine electric vehicles running on solar power, reducing pollution and making transportation more sustainable. Communities will have the energy needed to purify water, grow food, and improve living conditions. Space solar power is not just about generating energy, it's about empowering humanity to reach its full potential. By harnessing this limitless resource, we can create a world where energy scarcity is a thing of the past, and where every individual has the opportunity to thrive and succeed. Section 11. Conclusion. Reaching for a brighter tomorrow. The universe is filled with energy. The sun, our very own star, bathes our planet in a constant stream of power. Space solar power offers us a revolutionary way to tap into this cosmic energy source and create a brighter future for all humankind. This is not a distant dream, it's a tangible goal within our reach. The technology is advancing at an unprecedented pace, the costs are coming down, and the need for clean, sustainable energy has never been greater. Let us embrace the challenge, invest in the future, and work together to make space solar power a reality. The stars are within our reach, and the future is...